All right. So, and yeah, this is a short section, so we'll probably be done with the new material today. Okay, let's just get into it. Let me see. I can't think of any other announcements. I know that on My Open Math, I still need to post an exam 3 and a final. I might just go ahead and make those available, and then that'll be everything for the semester. Yeah, those are the only two things I noticed that were missing. So, but anywho, let's go ahead and finish this new material, and we'll kind of get into it. So we're continuing chapter 12 on statistics, and here we're going to be working on section 12.5, problem solving with the normal distribution. Some properties of the normal distribution. Sorry, you can get in. Let me just give it a moment. Some properties of the normal distribution: that it was symmetric, about the center, the mean, median, and mode were all in the center for a normal distribution. And then we kind of talked about it did work. Okay, good. Okay. Yeah, let's just kind of keep on. One objective here: solve for prior problems involving normal distribution. Okay. So we have this example on finding the percentage of data items less than a given data item. According to the Department of Health and Education, cholesterol levels are normally distributed. For men between 18 to 24 years, the average is 178.1 and the standard deviation is 40.7. What percentage of men in this age range have a cholesterol less than, let's see, 239.15? Mm-hmm. Okay, let me. So I feel like this is referring to the. I think it was the 68, 95, 99.5 rule or 99.7 rule. I had to go back and look at those numbers. But with that rule, right, if we have this, say here's our center, and I'm just doing a rough sketch, and here's our normal curve. I know that's a little off. It's also because I'm short on space. Let me see. So then, say we have this here, right, and this is like one standard deviation away from the center. This is minus one standard deviation. I think we said that 68% of the data lies within one standard deviation. So from there to there. Then I think the next one was like 95% was within two standard deviations. Those are supposed to be equally spaced, but my drawing's a little off. But 95% of the data is supposed to be within two standard deviations. And then once you hit 3 standard deviations, go a little further. All right, something like that. Something similar over here. All right. Let me shrink this down. And let me be consistent. Style, black. If you all are able to let your classmates in, you can let them in. Because it's just weird. Some people can like automatically get into the room, and some kind of seem like they get stuck. And I don't know how it works. I think you guys are letting them in. And then the final one was I think it was 99.7% of the data lies within 3 standard deviations of the average of the center. All right. And another thing we mentioned last time was that the standard deviation gives us a sense of the spread of the data. There was this whole formula for calculating standard deviation. And the simplest way to calculate it, in my opinion, is in a spreadsheet, right? I think it was like x minus x bar, the sum of the squares. Let me see. So we get the deviation, we square those, we add them up, I think we divide by n minus 1, and then we take the square root or something like that, right? So, okay, let me see. It says from in between 18 and 24, the average is 178 and the standard deviation is 40, right? So 178 would be here in the center. 178.1. Okay. And the standard deviation is 40.7. So then if we say 178 plus 40.7, I guess we can just use a calculator. Nope, that's not the calculator. Stop. Right there. I need to redo it. Yep. Yeah. Let's just do a new one. Yeah. Thank you. I was like, do I really have to go look for that file? All right. So if we have 178, come on, 0.1, and I hope I'm doing this right. Like this is just what comes to my mind. If it's wrong, we'll adjust. 178.1 plus 40.7. So one standard deviation up, we're at 218.8. So right here is 218.8. Let's do another one. So plus another 40.7. So then 2 standard deviations put us at 259. Okay, that's fine. So then 259.5 less than 239. Is that halfway between these two? Oh, I think now in hindsight, let me see something. So we got 259. Let me make that look more like a 9. Let me see, I want to find the average. I want to say that minus the 218, or actually, let's do the 218.8. I'm just kind of guessing and checking a little bit. 218. Oh my goodness, come on. 218.8 plus, we said 40. I'm going to say 40.7 divided by 2 because I think it's halfway. 40.7. If it's not, then we'll have another technique we can do. 40.7 divided by 2. 239.15. Okay. So the 239.15 is what? If that's 1 standard deviation, 2 is there. So it's 1.5 standard deviations from the center, right? One thing I think we talked about last time, which I just realized as I found this number. So let me see, the 239, I'll do it in purple, I guess. So the 239.15 is at 1.5, right? I think we mentioned a formula last time where we could have just jumped straight there. So I'm just going to move this over because I think we're still going to reference that. But that's giving us the z-score, right? Yeah, I think we're okay with what we did, right? So that's 1.5 standard deviations above the center. So then we're trying to figure out, okay, what percentage of the data is less than 1.5, right? So let's see. We know that this center region, here is 68%, right? Let's see if that's 50. Let me see. So here, let's do this. What is that, 34? So then this upper half of the blue, this is 34% here, right? Let me see. Now, if that's 95 for the two halves together, then half, let me see, 45, 46, 47. So then the upper green half would have been 47.5. Let me see. So if we did the 47.5 minus 34 divided by 2, right? 47.5 minus 34, let's round it up. Minus 34. What is that, a 5, 3? She's on it. Totally to get distracted. Oh, come on. Got it. Nice. Yeah, come on. And this one. All right. Come on. All right, that looks good. Okay. If that's, let me see. So basically what I'm doing, if this region is 34% and this region is 47.5%, I'm trying to find this region here. So I'm going to say the 47 minus the 34, and then I got to cut it in half, right? Let's see, 34, 44, 47.5. So then half of that is going to put us 6. I don't know why I'm trying to do this. 13.5 divided by 2, right? 6.75. Okay. So to get the percentage, we're going to say our 50%, which is the complete left half, plus the 34%, plus, what was that number we just got? Oh, no. 6.75%. Okay. What is that? 80, that's 84. 90.75%? That should be fine. Okay. So then what percent of men have a cholesterol less than 239.5? We get 90.75%. 90.75% is what I'm getting. Let me just kind of, well, first let me see if this is correct, and then we can recap how we got to this result, and we can kind of see, well, how did the text do it? Maybe they did it a different way, right? So I'm getting 90% of the men, almost 91. In this age range have a cholesterol less than 239.15. Okay, let's see, how do we do? Okay, so they did use the z-score. Compute the z-score, right? Okay. The table. Oh, wow, that's so interesting. That's not bad. Okay, so we did ours manually. I forgot about that table, but we would need the table. Okay. So we did it manually. We were a little bit off. Let me see, 50 plus 34. Let me see this. So I'll mention, I'll kind of explain what they did. Come on, clear. I don't even know I was doing it this way. 50 plus the 34 plus 6.75. 90.75. Okay, so what we should have done, we got to convert this to a z-score using the formula like we mentioned last time. So we take our data item minus the average over the standard deviation. That'll give us a z-score, right? And that's basically how far above the center we are. 1.5 standard deviations above the center, and I think we got that. Okay, let's keep going. So then we must find the percentage of men with a cholesterol less than 1.75. The table gives this percentage as a percentile. So there's a table in our textbook that we would have to use, right? It's a z-score table in the back. I guess we have to find a copy. I know I have it somewhere, but that's where this comes from. This comes from a table in the text. It's a table in the back. 93.32 of men between these have a cholesterol. So, we were close, but again, we would just use the table. This comes directly from a table in the textbook. Let's see if we can do another one similar, and let's see if we can actually pull that table and use it properly. Okay, so find the percentage of data between two items. So based on the way we just did the previous, this is actually going to be done in a similar way. We just have to adjust a little bit. Find the percentage of data items between two given items in a normal distribution. Convert each data item into a z-score. Here it is. Use table 12.16 to find the percentile corresponding to each z-score in step 1, and then subtract the lesser percentile from the greater percentile and attach a percent sign. So we're going to need table 12.16. Okay. I think earlier I said 12.61. Sometimes I am dyslexic. Okay. Table 12.16. Okay, let's see if we can find it somewhere. So in this example, it says the amount of time that self-employed Americans work each week is normally distributed with an average of 44.6 hours and a standard deviation of 14.4 hours. What percentage of self-employed individuals in the United States work between 37.4, and 80. So we need to convert these. Let me see. We need to convert these to z-scores and then use table 1216 to find the percentages. Then we're going to say the lesser percentage subtracted from the larger percentage, right? So I'll just label it as z1 for the first z-score. If we got this 37.4 minus the average, 44.6, divided by the standard deviation, 14.4. We use a calculator to get a number. Then our second z-score, we got 80.6 minus, and everything else stays the same. Pen down. I think we're all okay. You guys look good. I'll be updating attendance and videos. So I need to go and pull my recordings. Hopefully they haven't expired, so I don't have to redo them. I pulled, I try to get caught up whenever I can, and then I always have to stop for one reason or another. But I think wherever I left off, they should still be available. All right. So let's see, parentheses, we said 37.4 minus, actually, you know what? Let me do this. I'm going to go to my y equals, and I'm just going to do parentheses x minus 44.6 divided by 14.4, right? Because the only thing that's changing is that first term in either expression. Okay, so then I'm going to call on the function I just typed in. And when x is 37.4, this should be our z-score. So negative 1/2. And then when x is 80.6, (2.5). Okay. Okay. So we need table 1216. I'm just trying to peek to see if it's available here. I think we got this. Is the table here? No, it's not there. Okay. I do have it. Give me a moment. I'm gonna see if I can find this table so we can use it. Let's go like this. I needed to go to slide 10. Let's select this one, duplicate. No, there's not that. Okay. Yeah, give me a moment. Let me see if I can find this chart. Where would I have saved it? I think it might be in box. Let me check in box. Because I do remember using that. And I may have made it available as a handout. Go to Morris Brown. Go to my handouts. Factoring, it's not there. Let me check the notes. I guess I can go here. I know what else I can do. Let's pull up the textbook, right? I guess I can do it here. That won't be any trouble. I feel like it's gonna mess up my video if I do it there though. So what I'm doing, I'm gonna hop on the Populi right here. And if I don't quickly see it here, I have another place I can pull it from. I'm gonna go to our course. I'm gonna go to the syllabus tab or whatever, and then on the right hand panel is the textbook. Let me see, answers, chapter 11, chapter 12. Let me see, it should be in chapter 12. So all I'm doing is pulling up the digital text from Populi, so I can get the image to. Okay. Oh no. I clicked on the wrong thing. Let's try that again. Right here, chapter 12. I just need to be a little bit patient. Come on. If you're a little bit more patient, I need to hurry up and wait. All right. Come on. Okay. So now here's 12. It said 12.16. So I'm just scrolling. Let's see, 12.2. Let me just go down a place. This should be like 12.5. It's 12.2. Man, this is a long chapter. Let's go further down. Chapter summary, that was too far. 12.6, almost there. Back up a little bit more. I'm coming, guys. Okay, one more table. One more. We're close. Right. Oh no. Is that it? A portion. Yeah, that's just a portion. I want the whole thing. Where is the whole table? Is it in the back of the text? There it is. Got it. Got it, coach. Okay. That would be nice if I can. I'm going to make it as a handout in box. Give me just a moment. Pulling the copy right now. Oh no. Undo. Undo. Okay. Okay. So I'm going to share and send it to box. Save the files. Come on. Right. You are tripping. Cancel. Edit actions. What is it? More. There it is. This one. And I know it's going to want me to log in. Oh, thank goodness. I thought it was going to try to get me to log in. Okay. Fall of 23. Morris Brown. Let's put it into the handout section. Choose that folder. Load. Okay. Okay. So then I guess let me see. I'm going to share. And I'm just going to drop it onto the tablet. All right. Come on. There we go. That's fine. So what I'd like to do, now my device is just kind of like dragging. There we go. Photo. This one. Oh, I saw it. It was there. There it is. This one. Cancel. Okay, cool. And I'll just expand it as best I can to try to make it visible for you all. Oh no, you're throwing me off. Oh, that's totally gonna mess up my recording. Let's see about this. I don't even know how to put that back. Give me just a moment. This one. Okay, I think it's back centered. Okay, so this is about as big as I can get it. You'd have to pinch and zoom. So now, this is the table that we needed. 1216 z-scores with the percentiles. And so basically what this is telling us, with each corresponding z-score, it's telling us what percentage of the data lies below that z-score, right? Like for instance, if we go back to the previous example, we got a z-score of 1.5. So then if we look at the table at 1.5, z-score of 1.5, you see the 93.32 percentile. So that means that 93.32% of the data lies below that z-score. So for ours, we need to find the percentile for each of these z-scores. For negative 0.5, did I do that right? Let me check something. Yeah, that's fine. For negative 0.5, the corresponding z-score is 30.85%. So this percentile is 30.85%. And again, this table 12.16, I just made a copy of it available in box. The same way you access the notes that I post every day. You can, if instead of going to the notes section, in that same little area, you'll find a folder that says handouts, and that's where I put it into the handout section. And so you can use it. That's just a direct link. Okay, so then the 2.5, z-score of 2.5, right here, is 99.38% of the data. 99.38. Okay. So then all we're going to do is say the lesser subtracted from the larger to get the amount, the percentage of the data between these two z-scores. So then we're going to do 99.38 minus 30.85. Okay. So then we got 68.53. Those must be like two standard deviations. Anyway, 68.53% of the data lie between those two z-scores. Okay. Okay, let's see, how do we do? We got 68.53. There it is. So the 99.38 minus 30.85, this is the 68.53. So here we see, our average, our mu in the center. 68.53% of the self-employed Americans work between 37.4 and 80.6 hours per week, right? So 80.6 hours is here, 37.4 hours is here, right? And then with the 37.4, I think we found that it was 30.85% of the data is to the left over here, right? And then for the hours of 80.6, we had 99.38% was to the left, basically in this direction, right? So then we said the 99 minus the 30 to give us, so between the two is going to be 68.53. Okay. Really want to do some more of that. And I have some practice that we can do, but I think I'm just going to go ahead and do the last section. Missing. And let's kind of mention this really quick. So percent of data that is less than a given data item, where our z-score is B, and then we have our z-score. So if we're given like a data value, we convert it to a z-score, and then we use the table 12.16 to find the percent below. If we want the percent above some item, we still convert it to a z-score, and then when we get the percentile, we're going to subtract the percentile from 100, right? Because basically, the percentage below this curve is going to be 100%. So then, if we want the amount above, again, we find that z-score, and we find the percentage from the table. We subtract it from 100. Okay, and then this third case is like what we just found, to find the percentage between two z-scores. We find the percentage of each one. We find the z-score of each entry, and then we find the corresponding percentile for each entry. Then we subtract the lesser from the larger. All right. Okay. We're done with that. Let's hop back over here. Yeah, it was a little bit impromptu, but we found it. Okay. Okay, I think you're all okay. She keeps getting booted. I'm gonna just go ahead and let her in. Okay, testing. Yeah, we're good. Okay. And I think that brings us to the end of this section. So give me a moment while I go ahead and open up the next section.